Hi, I'm Brian Kettleson, and today I'm going to show you a feature from Azure called ACR build tasks. Build tasks allow you to update a container in the Azure Container Registry based on events in the base image or in the GitHub repository that it's linked to. So let's log into my computer and take a look at how build tasks work. You need to start by making a clone of my ACR tasks repository. The link will be at the end of this video. You need to use your own repository. It won't work in mine because you'll have to add a GitHub personal access token. Inside this repository is a tiny Go file that shows the runtime version of Go that was used to create the application. So it's a tiny web app, and the only thing that it displays is the name of the runtime that was used to create it. There's also a make file, and the make file is the recipe that we're going to follow for this app. So let's go into the application that I've cloned and take a look at the make file. First thing it does is call some setup tasks. If you run these in order, the demo will work for you. So the first setup task runs setup.sh, which creates a resource group, and it creates an Azure Container Registry, an ACR. The next thing it does is create an Azure Key Vault so that we can store usernames and passwords securely. The last thing setup does is create a secret in that Key Vault for a Azure Active Directory service principal, and that service principal will have a role that allows it to read from our registry. Then it puts the password for that user in a separate account, a separate Key Vault secret. So we'll have two secrets, one for the Azure username and one for its password. So let's go ahead and run the setup task by calling make setup. First it creates the resource group, then it creates the vault, then it will create the service principal and store the keys for the service principal's username and password in the vault. These take a moment, so while we're waiting, let's go back and look at the make file and see what's next. The premise of this demo uses a Dockerized application that has two different base images. The first base image is an exact copy of the Go Alpine image on Docker Hub, and I moved it locally so that I could show how to use both of them from a make file. And this uses Go version 1.10.4. The second base image uses Go version 1.11. So based on our main.go, which prints the version of the Go runtime that was used to compile the app, we'll see when we open the web page which version of Go was used. One of my favorite features of ACR is the fact that we can now use the build command to build Docker images up in Azure's compute. So I don't have to have Docker running locally at all. Let's run the make base command, which will first log me into my newly created container registry, and then it will build my base Go Alpine image from the Go 1.10.4 Docker file that I've created. So if I call make base, it's going to send my build context up to Azure, create the Docker image, and then push it into my newly created registry. We can watch that all happen in the terminal. You see that it's logged into my registry. It pushed the build context up just as if I were using a remote Docker image or remote Docker server on my local network. Now it's running the build tasks from the Alpine image, which is here. And that's pretty straightforward. It starts with an Alpine base image, adds some certificates, and then the necessary packages in Alpine to install Go. It uses a bootstrap version of Go, then it downloads 1.10.4, compiles it, and puts all of the binaries in the right place. So now we're doing that. We've installed the packages, set some environment files. It downloaded Go 1.10.4, and it's doing the bootstrap building. So we've got Go installed. The Docker file sets a few environment variables. And the last thing that happens is the image that was created up in the Azure cloud gets pushed into my registry. So this is the registry that I've created in my application in the makefile. You'll notice that all of the scripts that are called from the makefile source a single script called vars.sh, and this has a list of all of the names and variables that are used in the rest of the scripts and in the makefile itself. So when we source this file, it allows us to use variables, and you can replace these with names that you want to use. So all of the rest of these source vars.sh. One thing that is missing from vars.sh is the get PAT, the personal access token. The README for this repository has directions for you to create your own personal access token, but clearly I don't want you to have mine because that would be sort of bad. So now we have a base image that's pushed up to my registry, and it was actually built in the cloud. So let's create a watch, and this is the feature that I want to demonstrate today. The watch shell script creates a new ACR task based on my registry with a name of task Simple Web. It creates a new image called Simple Web with a tag of the run ID of the task. So every task has a run ID, and that increments. We're going to give it a registry name as an argument, and that will pass that registry name into the Docker file that's used. It uses my GitHub repository as the build context, so the contents of that Git repository will be cloned locally in the Azure cloud and used as my Docker context for the build. It's going to use dockerfile-app as my Docker file for the build. It will build from master, and it will use my Git personal access token. The last thing that this script does is call a run for that task to instantiate the task and run it for the first time. So let's look at that Dockerfile app really quickly. You notice that the from in the Docker file is actually a build time argument in the Docker file, and that allows us to use the variables from the vars.sh file so that you can replace my registry name with your registry name. So we've run base, now it's time to run watch. This will run the watch.sh command, and it's going to log into my ACR registry and then create the task and run it for the first time. Because the Dockerfile-app uses a base image called Golang with the Alpine tag, the one that we created in base was tagged Golang Alpine. So it's going to use the Go 1.10.4 base image that we created and tagged in the last step. So you notice that the watch, once it was created, immediately started to build my app, the main.go app, with the dockerfile-app Docker file. After it's built, it gets tagged with the run ID of the ACR task. This run ID is CA2. And then the last thing that happens is it gets pushed up to my registry. An interesting part of this is that as it's built and pushed, it finds the dependencies of my Docker container and noted that one of the dependencies was the Golang image. So any updates to the Golang Docker image in my registry will automatically trigger a rebuild of the containers that have my registry and the Golang image as the from in their Docker files. So now we have a run ID CA2, which is completed, and that means that the watch is created. So let's use this show tasks make target to see what happened in the background. Show tasks will show all of the ACR tasks that have been created and their output. So the first task was the creation of our watch, and the second task was the first run of that watch. So now we have a task named Task Simple Web on Platform Linux. It succeeded, and it was manually triggered from my bash script. That's really awesome. Let's take a look at all of the images that we have in my registry by using the make list target. One of the things that was a little bit difficult for me to grasp when I first started using ACR is that the command line lists my images using the word repository. So you can think of a repository in ACR as an image and all of its tags. So the ACR repository list first showed the list of base images that I have, Golang and Simple Web, and then it showed a list of tags for the Simple Web repository. So I have a Simple Web Docker image with a tag of CA2. In order to show that this works, let's use Azure Container Instances to run an instance of this container up in the cloud immediately. So the deploy.sh file calls az container create. This will create a public container with port 80, and it will pull that from my registry using the secrets that we stored in the vault earlier. So let's run make deploy. And that will deploy one instance of my Simple Web container at the most recent version of build task ID. In order to run this, you're going to need JQ installed locally. I think Ubuntu, it's just apt install JQ, and on a Mac, it's brew install JQ. This runs a subtask in my bash shell that gets a list of the tasks that were most recently run, and then just grabs the first one, the most recent one. So that's going to deploy the latest version of the Simple Web container up on Azure Container Instances, and the last thing it will do is show the fully qualified domain name of the container that was run. You'll note that nowhere so far in this demo have I used my local Docker command. This is all building, running, and executing up in the cloud. So the last thing it did was give me the name of the container that's running, ACR tasks-bkacrdemo.eastus.azurecontainer.io, And I specified that here in the DNS label, DNS name label, ACR-tasks-ACR name. So let's open a web browser, go to that, and it shows Go version is Go 1.10.4. So far everything's working as we intended, and you get to see the speed and power of ACI, which runs a container almost instantly right from your command line up in Azure Cloud. So we've deployed our container and we've proved that it's serving Go 1.10.4. Now let's update the base image. Let's call make update base. And this is going to use the Dockerfile -base 1.1-11 file, which will build a new base container and tag it with the Golang :alpine tag, which is the same tag that we use to build our application in our ACR build task. So what we're doing is replacing the base image from our application with a newer version. This is a bit of a contrived example, but it shows that when you replace a base image, the ACR build task will automatically rebuild images that use that base image in their from. Think of all of the base image vulnerabilities that have been exposed recently. I think Alpine had one with the APK package. I know Ubuntu has had several. So if you're using base images in your containers when you're deployed to production, you're going to want to have those base images updated to watch for security vulnerabilities. With ACR build tasks, that happens automatically for you. And I think this is just one of the most amazing tools that we've put out recently. So this update takes the same amount of time as the original base image creation because it's starting with an empty Alpine Linux container and it's downloading Go, bootstrapping Go, and then building and installing it. After that base image is updated, we'll go back and we'll use show tasks again to see what tasks were triggered automatically by our build task that we created. So now it's pushing our new base image up to my registry. The base image is pushed and the run ID was CA3. So let's run that make show tasks again. And we'll take a look at the tasks that have run. So most recently we ran and completed CA3, which was triggered by my update base local command. That built a new version of our base Docker image for Golang on Alpine. It built it up in the cloud in Azure, not locally. But because of our simple web task, it has triggered an automatic image update for my application, which is based on the Dockerfile -app, and it uses the Golang Alpine image. So while that is updated, our simple web task caught the fact that the base image was updated, and now it's updating my application image. I think that's really awesome. Security plus plus. Let's take a look at the tasks again, see how our progress is. All right, it says CA4 has completed and the image was updated as the trigger. So image update was the trigger for that. Let's go back and deploy again. We'll overwrite our ACI container with a new version that was built from our ACR build task. In the deploy script, you'll note that the name we gave this container is ACR tasks. So running this deploy script more than one time will replace the container that we've created in the first runs. So the deploy is completed. It shows us the fully qualified domain name of our application. Let's go back to the web, open it up, and now we've got Go 1.11. So we've proved that ACR build tasks will update our application container when the base file is changed, and it will also update our container if anything else in the repository is changed. So any git pushes to this repository will cause a new build to be triggered in ACR build tasks. The last thing we need to do is clean up, which will destroy our ACI images, it will destroy the vault, it will destroy our registry, and remove the resource group. So there's nothing left to be billed for. And while that's running, let's browse through the rest of this make file, which has some targets that you can use to test locally if you want to use your own instance of Docker. At no point during this demo did we use my locally installed Docker. All of the builds and pushes were done up in the cloud. But if you want to play with these locally, there's some tasks to build the base images for 11.04, 1.11, and run those. When our cleanup script is done, it will have everything deleted, and you'll be back to square zero. There's a README in the repository that lists some information about all of the tasks that are in the make file, and it has links to the documentation for ACR tasks, for Azure Container Registry, and for Azure Container Instances. I hope that you've enjoyed this video, and if you have any questions, as usual, leave them in the comments or reach out to me on Twitter @bkettleson. Thanks for watching.